Continuing on with page 3 and 4 of the bookwork, it's not really more difficult what we're doing here. The only difference is the algebra. Some of these problems you have to do a little bit of algebra to get them in the form where it's easy to do the derivative. Remember, we are used to doing derivatives if we have everything added together, kind of like that. If we have something weird like a plus b multiplied times c plus d, we do not know the derivative rules to do this derivative. So what we need to do if we have this is we need to multiply it out and put it in this form, and then we can take the derivative. Okay, so let's see. If we have a here, we have 4t times 9 minus t squared. To take the derivative of this, we would need to multiply it out first because we don't know how to take the derivative of a product like that. So we're going to multiply it out. We're going to have 4 times 9 times t minus, we're using the distributive rule here. And if your algebra is weak, good luck, okay? This would be 36t minus, and this would be 4t to the cubed, right? Now we're going to take the derivative because they asked us to take the derivative. If we take the derivative, we write dA dt equals, and the derivative of 36t is just 36 because t to the first turns into 1t to the 0, which is just 1. The derivative of 4t cubed is 4 times 3t squared. So our result is 36 minus 12t squared. Okay, that was A. So the hard part you can see is just the multiplication, not the derivative. Okay, what about C? Let's simplify this, multiply everything out. It's going to be t cubed minus 5t squared. If we take the derivative of this, it would be 3t squared minus 5 times 2t, which is equal to 3t squared minus 10t. Okay, that was C. Now E. A equals 5 minus t times 3 plus 2t. Now, to simplify this, we're going to have to use FOIL. So first we multiply 5 times 3, we get 15. Then we multiply the outsides, which is 5 times 2t, which would be 10t. Then we multiply the inside, so it would be negative t times 3, which would be negative 3t. And then we do the last term, so it would be negative 2t squared. So now we have it in a simplified format. We can combine these two and we can get 7t, right? So that would make it a little bit simpler. Okay. And then we're going to take the derivative. It will be dA over dt is equal to, the derivative of 15 is just 0 because the derivative of the constant is 0. Derivative of 7t is just 7 because the derivative of t to the first is t to the 0. Then minus 2t squared. Okay, so it's just that. And last of all, the derivative of g. So g, we just need to simplify that. Again, we're going to do FOIL. So we have t cubed for the first terms multiplied together. The outside terms multiplied together gives us negative t squared. The inside terms multiplied together gives us plus 3t. And the last terms multiplied together gives us negative 3. Now if we're going to take the derivative of that, then the first one's going to be 3t squared. The second term is going to be 2t. The third term is going to be plus 3, and the last term, which is, my writing is pretty bad here, but it's negative 3. The derivative of negative 3 is just 0. So you just disregard the constant there. Okay, now number 2. Find f prime of r. Okay, notice how they're like changing the variable constantly. It doesn't matter. Remember that any kind of variable that you're differentiating by, you treat it the same. So again, let's start with A. And first we're going to multiply everything out using FOIL because we don't know how to take the derivative of a product. So it's going to be 1/2 times everything. It's going to be 2r squared would be the first terms. The outside terms would be minus 6r. When I say the outside terms, I mean multiply this times this. The inside terms would be 3 times 2r, which would be plus 6r. And the last terms would be negative 6 times 3, it would be negative 18. So you can see that these two cancel out, right? So you're left with 1 half times 2r squared, which would be r squared. 1 half times negative 18, which would be negative 9. And this is f of r, right? And then if we're going to take the derivative of f of r, we're going to end up with 2r and then minus 9. The derivative of minus 9 is 0. Okay, so the answer is just 2r. What about c? So now first we're going to simplify. F of r is equal to, and we're going to multiply everything out. It's going to be the first two terms multiplied together is 4r squared. The let's see, the outside and inside terms is going to be negative 6, negative 12r. And the last term is going to be negative 3 squared. It's going to be plus 9. Now just to review how you do that, you go 2r minus 3, 2r minus 3. First you're going to do the first terms, 4r squared. Then you're going to do the outside terms, negative 6r. Then you're going to do the inside terms, negative 6r. And then you're going to do the last terms, negative 3 times negative 3, which is plus 9. And that'll give you 4r squared minus 12r plus 9. That's exactly what we got, right? Okay. All right, moving on. So when you take the derivative of this, the derivative of 4r squared is actually 8r. Okay, it's 4 times 2 times r, which is 8r. The derivative of negative 12r is negative 12. Okay, and the derivative of 9, constant 9, is a 0. All right, e. So f of r equals 3 times r plus 5 squared. Now we just multiply that all out so that we can take the derivative. And then when we take the derivative of this, that's f of r. When we take the derivative, f prime of r, first let's multiply everything out. We need to multiply everything out because we do not know how to take the derivative of a product. Okay, now we take the derivative. So 3r squared, the derivative would be 3 times 2 times r. The derivative of 30r is just 30. The derivative of constant 75 is 0. So our result is 6r plus 30. Okay? And next page. Now the only variation we're doing here is, okay, number 1. The trick to doing a derivative of a variable that's in the denominator is that you need to write it as a exponent. So if you have y equals 3 over x squared, you can rewrite that as y equals 3x to the negative 2, right? So if you do that, now you can still use the power rule. So you do y prime is equal to 3 times negative 2, you bring the exponent down, and then you subtract 1 off the exponent. Now when you subtract 1 off the exponent, it's not going to be negative 3 or negative 1, it's going to be negative 3, right? It's going to be 1 less, okay? So this is our result. It's going to be negative 6 x to the negative third. You can write that also as negative 6 over x cubed, okay? So that is the derivative of number 1. What about number 3? Y equals 7x to the negative 1. When you take the derivative of that, you're going to get 7 times negative 1 times x to the negative 2, which is equal to negative 7 divided by x squared. Now we'll do number 5. Y equals 5 over x to the 7th, which is equal to 5 times x to the negative 7th. If you take the derivative of that, it's equal to 5 times negative 7 times x to the negative 8th, which is equal to negative 35 x to the negative 8th. So you could say negative 35 over x to the 8th. Okay, that's number 5. Number 7. F of x equals 7 x squared plus 4 times x to the negative fifth. If you take the derivative of that, you get 7 times 2x, which would be 14x, and then 4 times negative 5 to the x to the negative sixth. If we're going to rewrite that, we would write 14x here, and then we'd have minus 20. And then x to the negative sixth is just the same as writing negative 20 over x to the sixth. Now we do number 9. G of x is equal to x cubed plus 3x to the negative 2. And if I take the derivative of g of x, then I would get 3x squared plus 3 times negative 2, x to the negative third. If I was going to rewrite that, I would write 3x squared minus 6. Oops, let me put that in the denominator. X to the negative third is equal to x to the third. That's number 9. Now 11. 11 is g of x equals 5x cubed minus x to the negative fourth. If we take the derivative of that, we get 5 times 3x squared, which would be 15x squared, and then this would be minus negative 4 divided by x to the fifth. Okay, do you get that? Because x to the negative fourth, the derivative of that would be negative 4x to the negative fifth, right? So that's what I wrote down here, okay? All right. If it's minus a negative fourth, we could also change both of these to a plus. So it actually is plus 4 over x to the fifth. Now we'll do number 13. Number 13, that's a fancy one there. Y equals x to the fourth over 8 plus 3x squared plus 5/6 x to the negative fourth. And you notice I just rewrote it so that all the exponents are in the numerator. Now I'm going to take the derivative. So it would be y prime equals 4x to the third over 8 plus 6x plus 5/6 times negative fourth. So that would be negative 26 x to the negative fifth. Okay, so it would be pretty much like that. I won't simplify that. It's not necessary in math studies. So 15 is here, negative x, or x squared minus 5/2 with x in the denominator plus 3 over 4x squared. So I'm going to rewrite that with all the exponents in the numerator. So I'm going to have x squared minus 5/2 x to the negative 1 plus 3/4 x to the negative 2. And then I'm going to take the derivative of that, dA dx. You notice that I put, in the denominator, I put the name of the variable. Okay, so in this case it's x. It would be 2x minus 5/2 times negative 1 times x to the negative 2. And the next one is going to be plus 3/4 negative 2 times x to the negative 3. And I could rewrite that. Oh my gosh, terrible writing, huh? I could rewrite that 2x minus, and it would be minus negative 1, so it would be plus. So it would be 5/2 with x squared in the denominator. I'm sorry, it's not plus, it's negative actually. Negative 2 times 3/4 would be negative 6/4, or we could also say it's negative 3/2. You could just cancel that out, it's 2. So negative 3/2, and then the x cubed is in the denominator. Okay? So that is the answer to number 15, and that is the end of page 4.